All right. Good morning, everybody. Welcome to another wonderful, exciting morning of chemistry with your host, me, Dr. White. Now, before I get into what we're talking about on Tuesday, by the way, since I teach every day of the week except Friday, I might say the wrong day when I say that, but I try and remember. I figure I'd do a couple of important public service announcements from your host, me. First of all, a number of you asked, or at least one of you asked a good question via email. Where's chapter one practice problems? Well, there are no chapter one practice problems because the only thing you have to know from chapter one that I talked about was what are the four branches of chemistry, and the best is organic. I'm an organic chemist. All right, the rest of the chapters have practice problems, but if you're ever concerned or have any questions, remember it's always going to be true in my course, in my life. There's no such thing as a dumb question. I say it and I practice it always. Now, another thing some of you may have, if you haven't ordered your chem kit yet, is having problem. If you click with your mouse on the link in my syllabus or online, when you open it up, you'll get the strange screen saying you're not registered or authorized or something like that. No, you got to copy the link and put it in your browser. Then it will work. Some of you had that problem and I helped you figure that out. Why it does that, I have no idea. All right, that's one thing. That's two things. Later today, we'll be doing, near the end of our time together, we'll be doing today's first lab, which is really discussing safety. And I'll talk more about what I put in the assignment area. And I'll go through that. Speaking about the assignment area, let's see something. If you look at Blackboard, you'll now see over here, you have something called assignments. And if you click on that, you'll see there are two assignments. The signature sheet, which I asked you to send to me as soon as possible, and you do that by uploading when you click on here. First of all, you can download either one to write in. If you don't have a printer, you can handwrite it out, and you will upload it through here. Also, you've seen I put this first lab, which is safety. I have things to download, and I have them both as a Word document and a PDF. So if you don't have Microsoft Word, and if you don't want to use Google Documents, I think it works, that's what it's called. I don't use it that often, like almost never. You can go either way. And that lesson, we'll talk more about lab safety later on. Now, a truly public service thing I like to do now is I was telling my organic class at the other college I teach, Elgin Community College, ECC, about something I thought about last night and said, no, I didn't think I should have had a V8, if you're old enough to remember those commercials. But I said, I should tell my Chem 1211 class about this, so I will. Years ago, and this is nothing that will ever be on a test, so you can relax. Years ago, I worked for this one chemical company where I was a senior research and development manager, otherwise known as an R&D manager. And part of my area of responsibilities were certain products that company made. And a lot of those products were sold to the petroleum industry, otherwise known by you as gasoline companies. And because of that, I got to know a lot about gasoline I never knew because I would go to their research centers, talk about molecules we have for them to purchase. And what I learned, tea break, I love today it's blueberry, wild blueberry. But anyways, I learned a lot about gasoline, so I thought I'd pass it along to you. First of all, and this is my personal opinion, but also The people in the industry felt that way, and I'm sure it's still the same way. The best gasoline is Shell. Always has been for at least since 1970s and ever since. Mobil is almost as good. Now, Marathon, I forgot either Mobil or Shell does their refinery, but that's quite good. The worst gas, and it's been this way for decades, is BP. It used to be called Standard, and BP is awful. What do I mean? Well, if you go to Google and search back about 4 or 5 years, you'll find in the Hammond area of Indiana and that part right across the border in Illinois, the refinery down there shipped bad gasoline to the gas stations in that area and destroyed, yes, destroyed the car engines of about 3,000 cars that BP had to pay to get replaced. That's awful gas. So stay away from that. Next thing I want to teach you, which I learned about in gasoline, is if you go to a gas station, you'll see there are 3 grades of the regular gasoline. Regular, whatever they call the middle, and the real expensive stuff. And they're different octane. If you were in my organic class, I teach you about octane. I teach organic at ECC. I no longer teach it at COD. That's another story, which I'm not going to get into. But anyways, the differences between those gasolines is performance. If you have a Lamborghini or a Ferrari, you should get the best. Shucks, I don't have mine yet, but hopefully someday I will. I have been in a Lamborghini Countach, awesome car. But anyways, for everybody, the regular gasoline works fine. I have a SUV and I've been using it. I've had a number of SUVs over the year, and that's the one I use, except about once every 3 or 4 months. And because of this is my preference, I never let my gas tank go below half. But about every 3 or 4 months when I'm driving normally, now I'm not, but when I am, I let the gas tank go down to a quarter, and then I'll go into a gas station. It's always Shell, sometimes Mobil, but usually Shell, and I'll put in the high premium gas and fill up the tank. One of the main differences between the different grades are what's called the additive package, which is the chemicals like I sold, or a company I work for sold to these gasoline stations or companies, petroleum companies. And the most expensive has the best additive package the most. And those are things that clean things in your car engine, like your carburetor tips, injector tips, and help keep your spark plugs clean and all that. But I have found over the years, and I've been doing this for, wow, a long time, that, like I said, once every couple of months, I'll do that. And I've never had trouble. I just knocked on some wood with that, with car engines. And that's a good thing. And I also do that about a week or 2 before, if you have to go in for your emissions test. I'll do that about twice every 2 years. You know how you have to get your Illinois emission test for your car? I do the same thing. And an important tip, if you're going in for the emissions test, right before you go to the station, go on the highway. I go on 355, which is that way, and I'll drive it for about 10 minutes one way and then come back 10, 15 minutes. I have a radar detector, so I'm usually in the 3rd lane. But anyways, and that helps heat up your engine and get rid of any gunk in there that would mess up the test. And it's always been worked well. All right, that's my public service announcements. If you ever have any questions about any of that or anything else, always feel free to come to my office hours Monday, Wednesday night, or email me. All right, let's get to work. All right, I was starting to talk about significant figures. When we talk about significant figures, whenever you measure something, you have numbers you get. And generally are always that kind of measurement, whether it's length, weight, volume, or even temperature. All but the last digit are known as certain, but the last digit is really uncertain. Now there's another type, exact numbers, which your counting items are from a definition. I'll teach you more about that. And one thing, everybody see the screen with the stuff on there? My thumbs up, people, can you see it? Thank you. I'm going to try calling later today, Zoom, see if I can convince them. Now, when we talk about numbers that you measure, you have to, for certain things, when you use those numbers, determine how many significant figures are in that number you just measured. And there are rules or guidelines for determining if you measure the temperature is 85.6 outside right now, how many significant figures are in that measurement. And that's something that is important in chemistry and in other things too. Plus, if you don't know this for my test, you're going to lose a lot of points. So that's important for you too. So what are the guidelines? I'm going to go through this. I will never ask on a test, what are the guidelines for determining significant figures? But I will expect you on tests 1, 2, 3, and 4 in the final to know how to do that. Because underneath your name and where you sign it, and you'll see this in test number 1, 2, 3, 4 in the final, it will say, please use proper significant figures for all calculated answers. And I'll be expecting that. And if you don't, I take off points. And I'm going to be teaching you that now. All right, first of all non-zero numbers are significant. So if you have a non-zero number, it's always a significant. Now, zeros may or may not be significant. Wow, that's really helpful. Let's go through this. Now remember, it will take a little while, but after you practice this, and it's in chapter 2, practice problems to practice this, you'll get it. And plus we'll do it in class today and also next week, practice it. Speaking about next week, time out for a public service announcement that I almost forgot. Next, let's do it Tuesday. Next Tuesday, first of all, hopefully you all have a calculator now. Your cell phone won't hack it on the test. If you don't, here's the type I suggested in the syllabus. It's the Texas TI 30XI IIS. It's in my syllabus. I checked last night at Walmart, and I think the Staples has it too. Walmart, we're selling these for $10.97 plus tax. My local Walmart in Streamwood had it. The other one, I think it's Elk Grove, had it too. I checked. And this is solar powered, so you never have to worry about getting a battery. This one, I think, is about 6 or 7 years old. It's quite good one, and it's cheap, and it's helpful. Next Tuesday, I will teach you in class how to use this. If you have a different calculator and you can't figure out what I'm showing you on this one, come to my office hours. I've yet to find a calculator that I haven't been able to figure out how to use. You have the big graphic calculators. Those work just as well. You don't have to do any graphing in my class, but they'll do the same thing as here. But you need a scientific calculator. Like I said, these are quite inexpensive. In fact, I was remembering back when I was in grad school, I hate to say this, about 74, 75, that's 19, not 18. The first handheld calculators came out from HP. They're about $500, which in today's dollars would be, I don't know how many thousands of dollars. And when the grad students I knew bought one, we were all looking at, wow, and why did you spend that much money? And next Tuesday, I'll show you how to use these. If you don't have one, buy one. You can get other models and everybody else's, but this one is cheap, it's real easy to use, and it works well. All right, that's the first thing. The other public service announcement, and I'll do it next Tuesday also, Years ago, for another class, I came up with a method for a student. I've taught it a number of times since that eliminates test anxiety. When you take a test or a final, if you get nervous and can't think well, I came up with a method that totally eliminates it. I've had students going from D's, C's, or F's in my class to being B's and A students. Plus, you can use it for your other classes too. And I will be doing that at the end of class, right after my lectures. For those who want to stick around, stick around. It takes about 10 to 15 minutes for me to do it. It takes about 10 minutes or so for you to learn it on your own or master it and practice it. And I'll talk more about it next Tuesday. Since I've tried to sell it once and I might try and sell it again on a DVD or something, I will not keep it on the video. But if you can't come to class, because this is asymmetrical, is that the right term? Asynchronous, brain freeze. But anyways, asynchronous, I will allow you to come to my office hours and I'll teach you there. All right, let's get back to work. I see some chat stuff. Do you hear the random clicking? Sometimes I don't hear it, but I wonder if it's my cables. Anybody hearing it right now? Is it gone now? Well, I don't know if it's a Zoom problem or mine. This weekend, I'm going to be, I apologize for it. I'm going to be redoing my cabling to make sure there's nothing. Because, hold on one second. Is that better now? If not, it could be a Zoom problem that I have no control over. But I'm going to be cleaning up my cabling, and I wonder, I apologize for it, but let's try something here. Because this is an identical setup I had this summer. All right, let's continue on. Just pretend I have a woodpecker behind me. Woody, be quiet. All right, let's get to work. All right, back to significant figures. All non-zero numbers are significant. Zeros may or may not be significant. All right, remember everything I show you on the screen right now, my slides are available to you in Blackboard. All right, and plus will be on the video that I'll post later today. Speaking of videos, Chem 1211 is alive and well, open for business. I've already posted, I know a number of you have seen it, the video for Tuesday's lecture, and this one will be on later today. All right, lead zeros at the beginning of the number are never significant. Confined zeros, those between non-zero numbers, are significant. Now, trailing zeros, those at the end of a number, are significant if a decimal point or decimal is present in the number. Trailing zeros, those at the end of a number, are not significant if the number lacks an explicitly shown decimal point. Let's go through this again. All non-zero numbers are significant. Zeros may or may not be significant. Doesn't help you. Let's continue. Leading zeros at the beginning of a number are never significant. Confined zeros, those between non-zero numbers, are significant. And trailing zeros, those at the end of a number, are significant if a decimal point is present, or decimal. And I guess I should have had point up here. Trailing zeros I guess it just fell off the screen. But anyways, trailing zeros, those at the end of a number, are not significant if a number lacks an explicitly shown decimal point. So what does this mean? How do we use this? Well, let's take a look. Oh, hint. Anyways, on the board, I abbreviated. On the test, I don't. All right, let's take a look at it. And it's how many significant figures are in, let's do a number. And the question is, how many significant figures are in 1,467? All non-zero numbers are significant. So 1, 2, 3, 4. So this has 4 significant figures. And because Dr. White loves to share the fun, I'm going to let you try one. How many significant figures are in this number? And you don't have to put it in the chat unless you want to. Well, let's give everybody time to figure it out. Time's up. Put down your pens and pencils. Remember, all non-zero numbers are significant. So 1, 2, 3, 4, 5, 6. This has 6 significant figures. Hold on, zoom. And you were right. All right, now let's do another one because there are a lot we have to practice. And the question is, and I'll do this one, how many significant figures are in this number? Well, non-zero numbers are always significant. Zeros, lead zeros, are not significant. Therefore, this number has only 2 significant figures. Oh, by the way, when I write a decimal, I always put 0 point. If you don't want to if you just want to ever write point, that's okay. But good habits, Dr. White doesn't change. And now your turn, D. How many significant figures does D have? See everybody already jumping in on chat. All right, let's do it. Now, non-zero numbers are always significant. Lead zeros are not significant. So if I look at this, this has 1, 2, 3. These are not counted, the ones that are underlined. So this would have 3 significant figures. And everybody who put down 3 were right. Thank you. All right, let's continue on. Let's see how much of the alphabet Dr. White knows. All right, let's look at this number. By the way, this is the way I write the number 7. And if we look at this number, how many significant figures does it have? Well, all non-zero numbers, let me do it first, and then I'll give you a chance to. All non-zero numbers are significant. Now, let's look at this zero. Notice it's in between two non-zero numbers. When a zero is confined in between two non-zero numbers, it's significant. So this is significant. So that has 1, 2, 3, 4. By the way, if Dr. White ever counts wrong, please correct me. And it's your time. I'm going to stop with the letters. How many significant figures in this number? Everybody getting involved, thank you. Makes my heart feel good. I like making my heart feel good. All right, let's do it. All non-zero numbers are significant. 1, 2, 3, 4. Oh, a zero, that may or may not. Notice it's confined between two non-zero numbers. So it's significant. 1, 2, 3, 4, 5. So this has 5 significant figures. Now, zeros at the end without a decimal point are not significant. And the question would be, in this one, how many significant figures? I'll do this one. Non-zero numbers are significant. Oh, zeros at the end. But notice if you take your magnifying glass and look here, there's no decimal point. I'll abbreviate because I'm lazy today. And therefore, these are not significant. The only significant figures, remember, zeros at the end, trailing zeros, no decimal point, are not significant. So this would be 1, 2, 3. So this would have 3 significant figures. Let's give you one to try. How many significant figures are in this number? Remember, keep your eyes on your own screen. I'm just kidding. All right, time's up. Let's take a look at this. Remember, all non-zero numbers are significant. Ooh, zeros. Is there a decimal point? No decimal point. And therefore, these zeros are not significant. And if I look here now, I have 1, 2, 3, 4. These are not significant, so I have 4 significant figures. Ooh, I'm going to let you try another one. How many significant figures in this number? I'm going to let you have some more fun. Don't tell the dean I'm letting you have fun. I don't think that's allowed. No, I'm just kidding. Andrew, that's an interesting question. And that would have 1 significant figure, but I haven't gotten to that yet. Okay. I'll get back to it. Ask me again in a couple minutes that number. And Andrew, you're welcome. Remember, all questions are good questions. Sometimes, since I don't have the chat minimized or it covers too much, let me try it over here. Maybe this will work. All right, let's get back to work. Because the clock is ticking. Actually, I have electronic digital and it doesn't tick, but you get the message. All right, all non-zero numbers are significant. Ooh, we've got lots of zeros. Let's look at this one. It's confined between two non-zero numbers. Therefore, this is significant. Oh, we've got zeros here. But notice, no decimal point. Therefore, these are not significant. And now, if I go back, I have 1, 2, this 0 is significant, 3, 4, 5. Therefore, this has 5 significant figures. Now, numbers with a decimal point, the zeros after that are significant. And if I look at this number, how many significant figures are in there? All non-zero numbers are significant. And look, there's a decimal point. And therefore, zeros after the decimal point are significant. So this would be 1, 2, 3, 4. And that would have 4 significant figures. Let me do another one. If we look at this number, all non-zero numbers are significant. 1, 2. Oh, look, we have a decimal point. We already know these are significant, and turns out this is significant too. So this would have 1, 2, 3, 4, 5. And therefore, this would be 5 significant figures. And it's time for Dr. White to share the fun. How many significant figures in that number? All right, Rhea, you asked over here, why would this be? All trailing zeros at the end of a number when there is a decimal point are significant. Even though it's on this side of the decimal point, when it's at the end of a number with a decimal, and notice this is after this, meaning after the non-zero numbers, that's why that would be significant. Good question. Thank you for asking. Remember, all questions are good questions, my class. All right, let me do one thing I should have done earlier. Hang in there. All right, let's do this one. Non-zero number, non-zero number, non-zero number, non-zero number. Those are always significant. A 0, it's after the decimal, or in the number at the end with the decimal. Therefore, it also is significant. So this is 1, 2, 3, 4, 5, 5 significant figures. All right, let me give you a challenge. Are you guys up to a challenge? How many significant figures in this number? Oh, by the way, is the chirping noises still coming in irregularly? I apologize for this. This weekend, I'm going to totally redo my rat's nest, the cables, but I will tell you, the setup is identical to what I had this summer, and we didn't have that problem. I wonder, I don't know what it is, but I'll get down to it and solve it somehow. Let's try something. I was playing with my camera cables, which is also the microphone. Let me know if that's better. All right, let's get back to this. How many significant figures? All non-zero numbers are significant. 1, 2, 3. Notice I have zeros, they may or may not. These are both confined. Therefore, these are significant. And finally, I have these zeros, and notice there at the end, there's no decimal point there. Therefore, these are not significant. If I come back here, I have 1, 2, 3, 4, 5. Uh-oh, I've used 5 3 times in a row. Does that mean, like in Monopoly, I have to go to jail? All right, let's do one more because these are fun. How many significant figures does this number have? Ooh, scientific notation. I'll give you 8.6 more seconds. 8.2, 8.5, time's up. All right, this is scientific notation. When you're doing scientific notation, you ignore this totally. And if we look at the number 7.63, all non-zero numbers are significant. 1, 2, 3. Therefore, this has 3 significant figures. Why don't you try one more? How many significant figures does this number have? All right, let's take a look at this. This part you ignore. All non-zero numbers are significant. Oh, look, we have a decimal point. And zeros after a decimal point are significant. So therefore, these zeros are also significant. 1, 2, 3, 4, and this has 4 significant figures. And that's how you do significant figures in scientific notation. Now, significant figures has a very important role, especially when you're doing calculations. And I'll be teaching you that. And one of the things you have to do when you're doing calculations is rounding off. By the way, exact numbers have no uncertainty. If I asked how many people are in the room in my classroom, you're never going to tell me 28.7 or something like that. If you say there's 250 people in the room, that's an exact number, and I'll teach you exact numbers don't play a role in calculations. Now, when you're dealing with significant figures, you will have to at times round off numbers. It's called converting one significant figure to another. Say you had 4 significant figures and you had to convert that. We call that rounding off to 2 significant figures. And what we're really doing is the process of deleting unwanted, non-significant digits from a calculation. And some of this you might be familiar with. When we talk about rounding off, if the first digit to be deleted is 4 or less, then you simply drop it from all the digits, all the following. If the first digit to be deleted is 5 or greater, that digit and all that follows are dropped, and the last retained digit is increased by 1. So this is a rule. If it's 4 or less, you're going to drop everything. If it's 5 past that number, you're going to delete and everything past it. If it's 5 or higher, you will add 1 to the digit before the one you're deleting. And now you're looking at that and saying, what? Well, let's go through some examples. Oh. All right, hold on. All right. Blackboard was playing games with me, didn't want me to switch over. Let's look at this number. And the question is, round this off. And let's say 3 sig figures. So you say, this is my first significant figure, second, third, this is the number to round off. Is that 4 or less or 5 or higher? By the way, you have to know which numbers from 0 to 10 are larger and smaller. And you notice this is 4 or less. So I'm going to drop that, replace it with a 0. And that's how you do it. Now, if I took this one, I want to notice this is 3 significant figures, 1, 2, 3, 0 at the end with no decimal is not significant. Now, if I wanted to round this off to 3 significant figures, 1, 2, 3, and then the next number is what I use to round off. And now, is that 4 or less or 5 or higher? Time's up. Hopefully I'll pick 5 or higher. Therefore, I'm going to drop this, replace it with a 0, and increase this by 1. And that's how you do it. Now, in reality, in my class, you're going to be using scientific notation most of the time. And let's look at a number. How would you round this off? Let's say 2 significant figures. First number that's non-zero would be, you keep, this is 2, and this is the number you round off. Now, how do you do that? Now, with a decimal, one like this number is 5 or greater. I'm going to drop that and increase this by 1. So this rounds off to 4.4 times 10 to the 4th. This part never has a role in rounding off. And I'll be teaching in a little while how to round off numbers or rules for when you do different types of mathematical calculations. So let me have you, let's do one more though. And how would you round this off to 3 sig figures? And I'll do this before I share. Keep this, keep this. Notice this is a 0 after a decimal. Therefore, this is my 3rd significant figure. And This is the one to round off. When it's past the decimal, you would then just drop it because it's 4 or less, and this would be 5.60 times 10 to the fourth. Now you're all going to be doing, I lied, I'm going to do one more myself. You're all going to be doing calculations on a calculator, and a calculator spits out large numbers. Let's look at one. Say you did a calculation on your calculator. It gave you this number, and they will. 8.735613 times 10 to the 8th. And the question is, round it off, let's say 3 sig figures. How do you do that? First non-zero number, keep. Second significant figure, keep. Third one, you keep. This is the one to use to round off. Is that 4 or less or 5 or greater? Hopefully I'll pick 5 or greater. Therefore, I'm going to delete all of this and increase this by 1. And therefore, remember, this part doesn't change. And that's how you do it. So it's time for Dr. White to let you have some fun. Why don't you round this off to 3 significant figures? Ria, I see your question. So zeros only count as significant if they're after a decimal point or between 2 significant figures and or non-zero numbers. And the answer is yes. All right, let's take a look at this. If I want 3 significant figures, this is my first one I keep, second one, third one. This is the one to round off. Is that 4 or less? The answer is yes. Therefore, I'm going to drop it. And the answer is 9.46. This part doesn't change, times 10 to the fifth. And that's how you do it. If I look at the clock, it's time for a 5-minute Dr. White stretching break. So I'll see you at 10:55 because I'm going to go stretch. All right, everybody back? Are we ready? I'll give you another 30 seconds if you're not. Is that clicking sound still going on off and on? I apologize. Like I said, probably today or tomorrow, I'll check all my cables, but they're new cables and I really don't know what's causing that because I haven't changed anything really, but I'll work on it. All right, well, like I said, I'll work on my cables and see if there's some sort of signal there because my fan's off and hold on, if I don't move, is it clicking still? No, is it clicking? I bet my chair wheels are hitting a cable. If I move now, is that clicking? All right, I think my chair is hitting one of the cables. Hold on, let me get the crazy glue out and I'll glue my chair. No. That's weird. Well, anyways, I'll work on it. All right, let's get back to what we're talking about. Significant figures. And we're talking about how to do significant figures and rounding off. And I don't think I gave you a, well, I did, let's do a couple more. Why don't you round this off to 3 sig figures? Dr. White likes 3 significant figures. On Tuesday, I'll tell you why. You're just going to have to wait. I think everybody's done. Let's do this. This is the first one I keep, second, third. This is to round off. Is that 4 less or 5 or higher? 5 or higher. I'm going to drop that. And therefore, and I'm also going to increase this by 1 because it's 5 or greater. Oh, let's do one more. These are fun. Maybe 2. Why don't you round this off? Let's get out of my rut. Round that off to 4 significant figures. All right, time's up. Let's take a look. We look at this, we keep the first significant or not significant figure, second, this is a 0 that's confined, past the decimal point 2, 3, 4, and this is the one we use to round off. And now Is this 4 or less or 5 or higher? 5 or higher, obviously. I'm going to drop that, increase this by 1. This stays the same, 2.80. Now 4 times 10 to the minus 4th. And that's how you do it. Let's do 2 more, and I'll explain why, because it's time for a Dr. White story. Round this off to 2 significant figures. Anybody need more time? All right, let's look at this. We'll keep this one, keep this one. This is 4 or less, so I'm going to drop it, and this becomes 95. Let's do another one. Round that also off to 2 significant figures. All right, time's up. We keep this because non-zero is a significant figure. This is 2. This is what we use to round off. And this is 4 or less or 5 greater. It's 5 greater. I'm going to drop that and increase that by 1. And this also becomes 95. Now, what's the reason for doing this? Well, it's time for Dr. White's story. Remember, I told you you'll learn a lot about me this semester. Well, a long time ago, I worked for this one chemical company. Then it was called CHEMI. Now it's AkzoNobel. And I was our senior R&D manager. And part of my responsibility was to help solve production problems. And the vice president of production called me up, and I already knew about the problem, that one of our suppliers, someone who sold us chemicals that we used to make something else, we were having problems with the quality of their product they were selling us. And that was causing us problems, which is not good. So I was asked, go and solve their problems. So I called them up and said, let me come down and talk to you guys, because we're having problems. Well, sure enough, I solved their problem. And things got better. Well, a couple months later, the CEO of that company called me in and said, could you come in and talk to me? I said, sure, why not? And it turned out it was an interview for a job. Their research manager, who also managed their quality control, was retiring. And they were looking for a new R&D manager, or actually this, what was the title? Laboratory manager. And I said, well, I'm sort of, I don't know. And the CEO said, well, after he talked to me, he called me back and said, I really like you. And I said, well, what can you do for me? And lo and behold, they said, here's the salary we'll give you. And the salary they offered me was double, yes, double what I was being paid. Guess what? Goodbye, old company, I'm coming to you. Well, now this company that I'm now working for, we're selling our products to the company I used to work for. And any chemical that's sold has specifications. Specifications are certain measurements that must be met. If they're not, the company receiving that chemical can say, this is out of specification, take it back. We don't want it. Just like if you go buy a car and you want a red car and you go to the dealership and the one they have for you is green. No, that's not what I wanted. That's not what I specified. Well, it turned out for when you're selling chemicals and buying them, you have contracts. In the contracts, you have various measurements, specifications that are written down. And this one product we were selling, this company, the name of the company I was now at, then it was called Unichem Chemicals. It's since been sold to someone else, but then it was part of Unilever. We shipped something, and a certain important specification called iodine value, which I won't teach in this class, specification in the contract was 95. Any chemical that's shipped from a company has what's called a certificate of analysis. Some companies call it C of A, others call it a cert. I like calling it C of A. And it has the different things they measure, specifications, and it's always signed by the laboratory manager, me. And if it's not signed, it can't. The guard at the company shipping it will not let anything go off site if they don't have a C of A. Anyways, spec was 95 minimum. We measured it in my lab. It was 95.2, which was sort of close to the specification, but it was over. But we had to ship it. And these were 4 tank wagons. Tank wagon holds 40,000 pounds. Those are the things that deliver gasoline to your gas station or chemicals elsewhere. And we're shipping 4 of them. That's $200,000 in chemicals, because that was $1 a pound. And when you're working at a company and you receive a product from your supplier, you usually test yourself some key specifications. Well, the company we sent it to, I used to work for, the plant that got it, I used to go there and solve problems. So I knew all the people there. And guess what? They measured and got 94.8. And the QC, quality control manager, called me up, because that was Mike, and said, Ken, Dr. White, we got this stuff from you and it's 94.8. That's below specification. I'm shipping it back. And I said, hold on a minute. And I knew this guy quite well. We'd worked years before when I was at the, I said, do you have a copy of the contract? And he did. And I did in my office, open it up. What's the specification for iodine value? And he said 95. And I said, how many significant figures? He said 2. I said, my number is 95.2, round that off to 2 significant figures, 95. Your number, round 94.8 to 2 significant figures, 95. Guess what? You can't ship that back. Well, he couldn't. Well, one, I was upset because I didn't want to make him feel bad, and he was really, excuse the language, pissed at me big time. And I promised him at that point, I said, look, I apologize on this. From now on, even though the spec is 95 minimum, we won't ship anything to you less than 95.8. And plus, next week, I'm going to come down. This is in Morris, Illinois. I'm going to come down. I'll take you out to dinner, which I did and got him good and drunk. So he was happier. But don't say that. Company paid for that too, because I had a company credit card. But that's another story, another day. And then afterward, I went to the production manager and had a meeting with him and my boss, who was the vice president of technical. I said, look, this is a hassle I just have to clean up to the production manager. I will not sign a certificate of analysis for this company if it's less than 95.8. At that point, the production manager went ballistic on me. I said, what are you going to do? I'm not going to sign it. And my boss agreed with me. He was both our bosses. And later on, Mike, who was from Australia, the production manager, came to my office and apologized. And I took him out to dinner too and got him good and drunk. Alcohol works good, especially if you know how to hold your liquor and other people don't. So significant figures play an important role in everyday life in industry. It's not only that, if you buy something like a screw or a nut, there's certain specifications. Yep, that's one of them. It never hurts to take someone out and make them happy. Well, I can't tell you this, that company and the other company, I had American Express credit card that at that point I had about a $25,000 limit. All right, let's get back to work. So now you know the rules about rounding off. Why do you need to use these rules? And let's take a look. By the way, I did a switch, just quick thing. Thumbs up, people. Can you see my slides? Thank you. All right, now, when you do a multiplication with significant figures or division, the number of significant figures in the answer is the same as the significant figures in the measurement, meaning the number that contains the fewest significant figures. Again, in multiplication and division, which you're going to do a lot in my class, all the math you're going to do, I'm going to teach you how to do also. So relax, take a deep breath. The number of significant figures in the answer is the same as the number of significant figures in the measurement that contains the fewest significant figures. Let's take a look at an example of this. And the question is, with proper significant figures, what, and hopefully you all can see this. Let me check with my thumbs up, people. Everybody see it? 4.00, thank you. Again, that's a problem with Zoom. I don't always, I think I switched and didn't. So let's look at this one. How many significant figures in this number? And the answer is 3. 4 plus 2 zeros past the decimal. How many here? And the answer would be 2. This and this. And you all know for it, at least I hope you do. I don't know, nowadays with kids using only calculators, I don't think they teach the multiplication division tables like when I went, but this is 2. That's 1 significant. How do you make it 2 significant? You go like this. And that's where you'd have to round up. Or if we did this, let me do another example. Hold on one second. I'm about ready to open a spreadsheet. All right, hopefully you all see the spreadsheet on there. Thumbs up, people. You see a spreadsheet A and B and all that? Can you see it? Okay, thank you. All right, let's do the same, not the same thing. Let's do and if you notice this number, and I had 22 divided by 7. I have it set up in scientific, let's just remember 22 divided by 7. You notice that my calculator gives me a ton of numbers here. Now, all right, hold on one sec. Thank you for letting me know. Also, if you can't see, now do you see it? Those of you on chat, if you can see it, can you see it? Put yes. Thank you. All right. Also, if you can't see something, open your mic and say, hey, I can't see it. All right. Now, 22 is 2 significant, 7 is 1 significant. So the answer to this, what is the proper significant figures? 22 divided by 7, and the answer is 3, because that's only 1 significant. You have 2 and 3, 1. Therefore, you round this off to 1, keep the 3, everything else gets dropped. And that's where you need to use significant figures. Let me show you another one. Now, the E in a spreadsheet means 10 to the power, so this is 2.41 times 10 to the third, divided by 4. Hold on 1 second. I always forget to do this. Divided by 4.444. Now, before I hit enter, how many significant figures in the first one? 3. How many in the second one? 4. My answer should, because it's a division, have the same number of significant figures as the number with the lowest. So therefore, it's 3. Now, if I hit enter, here's what my calculator. So how do you round this off to 3 significant figures? You keep the 4, keep the 8, keep the 1, 5 I round off, and that's 5 or greater. I'll drop all this. Let's do something. I've never tried this before. Ah, look out. I can write on a spreadsheet. You round that off, and this becomes a 2. Turns out in a spreadsheet, it gives me a much broader pen. Let's try something. Yeah, does strange things, but anyways, let's do another one. I'll let you try one. Now, both the numbers I had 4 significant figures. Why don't you try what would be the correct answer? Because if you put this down on a test, I'm going to take off a point. Remember, both were 4 significant figures. This was a multiplication. And therefore, you should have 4 significant figures. I keep this, I'll keep this, I'll keep this, keep this. This I use to round off. It's 4 or less, so I'm going to drop all this. So the answer would be 2.328 times 10 to the 13th. So whenever you multiply and divide, the number that you get should have the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. Quick question, is the clicking still going on and off? Sorry. I'll work on that today. Before Tuesday, I'll have it solved. Or maybe I have a woodpecker in my wall of my house. I hope not. All right, let's look at the rules for addition and subtraction. And this class, way later on, you'll be doing addition. I can't think of any subtraction we really do. Now, this one's a little funky. It took me a while to wrap my head around it, but it's the rule, and I can understand now why it makes sense. The answer of an addition or subtraction has no more digits, significant digits, to the right of the decimal point than are found in the measurement with the fewest digits to the right of the decimal point. Remember, all digits past the decimal point, 0 or not, are significant. And this one I don't need a spreadsheet for. Let's look at this. If I add these up, what would my answer be? Well, if I did it on a calculator, if I can do it right, I would get this, which is not correct. Why? because you look at the number of significant figures past the decimal point. This has 2. This has 1. Therefore, the number of significant figures in your answer should have the same as those past the decimal, which 1, 2, which is lower. Hopefully I'll pick 1. Keep this, use this to round off. And what do I get? This rounds off. Keep this. This is 5 or greater. This gets dropped. This gets increased by 1. And the correct answer is this. Let me show you another one. I add this. This is what your calculator, this is not the correct answer. You look at how many numbers are past the decimal, because all numbers past the decimal are significant. This has 3. This has 2. Which is a smaller number? Hopefully you pick 2. So you round this off to 2 past the decimal. Keep this, use that to round off. That is 4 or less. I'm going to drop it. And to this number, using significant figures, the correct answer would be this. Let me give you one to try. Why don't you try adding this up, and what would be the correct answer using proper significant figures? Did that just click again? Because I just moved my chair. Is clicking happening now? All right, I think I figured out how to do this. I got to put some stuff on my wall to get it. So for Tuesday, I think I solved the problem. See, I told you Dr. White can solve problems. Speaking of solving a problem, I better do this one. You're all sitting there, get to work. I will. If you added it up, but you have to use proper significant figures for addition. And like I said, we're not going to do subtraction, which is why I'm not showing it. We have 1, 2, 3, 4 past the decimal. Here we have 4. Here we have 1, 2. And therefore, this has 2. Remember, we're only looking at past the decimal. So we want to have the lowest number past the decimal, 2. We'll keep this and this. This is used to round off. Is that 4 less? The answer is yes. This gets dropped. And our correct answer, assuming I did the addition right, which I did, would be 5.36. Let me give you another one. Hold on. Oh, I forgot to mention, I better mention it now. Uh, how many of you have heard of Dr. White's 5-second rule? Give me 5 seconds after I write something down, because sometimes I'll see it's not a good, let me get this away from here. All right, why don't you do this one? What would be the correct answer for this problem using proper significant figures? All right, I see it. Let's do this one, and I'm going to go back to the one I just did, because based on what people are writing, I see a concern that I have to clarify better. All right, looks like everybody's done. Let's do addition. Hopefully that's 7.6815. Now, here's the thing you have to remember. When you're rounding off addition, you only consider the numbers past the decimal point. You don't ever touch the ones to the left of the decimal point, and you don't use those considering your final answer. Only past the decimal point. This has 3 past the decimal, 2. So I'm going to keep this one and this one, and I'm going to use this to round off. That's,
Professor,
yes,
it's 7.6915 or 7.695.
thank you.
Yeah,
Well, thank you very much. Like I said, I don't walk on water unless it's frozen. Even then, I try and stay off it. Thank you. All right, so this has 2, this has 3, and therefore, to round off, I keep this one, I still use this to round off. It's 4 or less, drop that, and the correct answer is 6.9. Now, let me clarify something. When we're looking at addition, even though this number total has 3 significant figures, when we're adding, I only look at the number of significant figures. Look out, I'm going Technicolor on you. Past the decimal. You don't worry about anything to the left. You never change that. And same thing here, I forgot the decimal point. This would be 3 significant, but again, this was 2. And again, you only consider past the decimal. And that's how you round off addition. We won't be doing this for a while, even though soon we'll do multiplication. But for this, when we get to it, I'll go through this again. When you're doing exact numbers, those are never used in determining significant figures. When we get to a point, I'll remind you of this. All right, let's talk about measurements. And for the next couple of slides, click the switch. Will this be on a test? Is off, but it's a good review, so that's why I'm going over it. When you measure something, the 2 most common systems are the English system, which we use in the United States, like what's the temperature outside? Let's just say 85 Fahrenheit. And then metric, what's the temperature outside? Well, it could be 18.6 Celsius. Another one in metric, what's the volume of the pop bottle you just bought? Oh, it's a 2-liter. English, how much gasoline did you just buy? Well, 5.5 gallons. So they're 2 different systems. And the metric, the switches off for this well as beyond, comes from the Greek word metron. I don't speak Greek, but I've read that in books. And when we talk about length, and again, switches over, key length of meter is 100 centimeters. A kilometer is 1,000 meters. Volume, and we'll talk more about this when we get into solutions, which I'll teach you what a solution is. And the key one is a liter, which is 1,000 cubic centimeters, abbreviated by cm cubed, or also known as 1,000 milliliters. And 1 millimeter equals 1,000, not 1,000, 1 cubic centimeters. And if the label is still on my water bottle, I reuse these, it would say this has 710 milliliters, and also give it in English too. Now, the metric unit, mass unit is a gram. Now, it's the matter, total quantity of matter, but weight is force. But since, I think I asked this the other day, but I'll ask it again, how many of you are going to be leaving this planet in the next 17 weeks? And the answer is none of us. Therefore, I'm going to use weight and mass interchangeably. And in the metric system, the main unit of mass, grams, is also equal to 1 kilogram, is equal to 1,000 grams. By the way, if you ever watch Miami Vice, which unfortunately I don't see anymore, or if you see any movies or TVs, crime movies or anything, and they're smuggling in illegal drugs like cocaine, you'll hear them say, how many keys are coming in tonight at midnight? And keys is short for kilos, which is short for kilograms. For some reason, drug smugglers, at least in the movies, and I don't have any firsthand knowledge, always use the metric system. I should point out, having worked for 2 international companies, AXO was one of them. I spent a lot of time in Europe, so I know both the metric and the English, because in American plants, we use pounds, where in English plants, or German I've been in, Dutch, and French, they use kilograms. All right. For this slide, click, switches on. There are a few things I would like you to know that are important on this slide. Let me get to it. Now, prefixes mean something. Gram, a kilogram is 10 to the third, or 1,000 grams, and kilo is the prefix kilo means 1,000. You should know this. I'm going to be subtle. Dr. White's being subtle. Now, mega, like how many megabytes you have, is a million. Giga, how many billion. And that one's just interesting to know, but you should know centi, like centimeter, that's 100th, 10 to the minus 2. You should know milli, like in milliliter, and that's 1,000th. So milliliter is 1,000th of a liter, which are abbreviations. So these are all, these 3 you should know. Now, micro is smaller. I'm not going to ask you to learn that. One more on this chart, nano, right here, and I'll change pen so you don't, right here is a billion. And if you've been following chemistry for the last, since 1995, there's a whole new group of chemistry called Nano Tubes, which are tubes and other nanomaterials that are like a billionth and of a millimeter or centimeter, and they're very tiny, but they're very strong. And both American and many European and Asian governments have been spending billions of dollars in nanotechnology. And a lot of it's already out there, and it's making a big difference in our life. But from this table, you should know kilo. By asking on a test, what does the prefix kilo mean? You can either put down 1,000 or 10 to the third. By asking on a test, what does centi mean? 10 to the minus 2 or 0.01, 100. By asking on a test, what does milli mean? Like in milliliter, you should know it's 1,000, 0.001 or 10 to the minus 3. Click, switches off on the next slide. Now, one of the things I do in my lecture slides is, even though I told you, don't buy the book, I follow what's in the chapters, and sometimes I move chapters around. And if you were reading the book, you'd see they have a part called, wrong slide, called problem solving, and I know it as unit analysis. And by the way, you'll learn later in the semester that when I teach you unit analysis, you'll find out unit analysis is your good buddy and your good friend. It helps you from having to memorize a lot of stuff. Once you know unit analysis and you're doing some math, everybody relax, take a deep breath. When you're doing some math, you use unit analysis and it makes your life so much easier. It's made mine so much easier. That's a general problem-solving method which units associated with numbers are used to guide in setting up calculations. We're going to skip this because we're not going to use this for a couple of chapters. And if I taught you now, it wouldn't help you learn it because you're not going to be using it now. And you'll forget it and I'd have to do it again. I hate wasting time. All right. Next slide. Let's talk, and they throw this in here in every book, density. Switch is still off. Now, what's density? It's the ratio of a mass of an object to the volume occupied by that object. So density is mass per volume. Mass divided by volume. Now, I'm not going to write anything on the board, but I'll teach you again when we do the lab. And that is higher density things sink in lower density things, and the opposite is lower density things float on higher density liquids. And what does that mean? Here you have a bucket of water. And if I put a cannonball in there, which is heavier, higher density, which is lead, than water, it's going to sink all the way to the bottom. If I put a feather on top, by the way, you can all laugh your head off, it's going to float because the feather has a lower density than water. That won't be on the test, but we'll be doing a lab about density, and it's fun to do. All right, just a reminder, we're going to go a little longer today than we did on Tuesday. That's in the syllabus because let's take a 5-minute break and then we'll do our lab today, which will be pretty short and you'll get out earlier. So let's take a 5-minute break, come back at 11:45, and I'll see you then. I'm gonna do some more stretching. Give me a second while I'm opening up some other files. By the way, if you ever see my name on your screen, all that means is I've shut off my video lead feed, which I can do, and you can do too for your own. All right. All right, let's get started so I can get you out early, which is a good thing. I'm sure you'd like that. And one thing I was just thinking, I have a new office chair. My old one of 25 years finally died. The gas lift cylinder, and they don't make those for that chair anymore. And the ones you can buy on Amazon or elsewhere don't fit that. I found that out the hard way. And this new one, which is really, really amazing chair. It's a steel case Leap chair, which retails for about $800. I got a used one for $300. Is heavy and metal. I think that's part of the problem with the clicking. So anyways, let's get to work. It's time for lab. First thing I should tell you about lab is whatever we do in the lab will never be on the hourly exams or final unless I talk about it in the actual lecture part. I'll say that again. The only thing I put on my test and final are things I talked about in what I call the lecture part. We're now in lab. So this makes lab a little less stressful, and you'll be handing in labs. Now, if we go to Blackboard, if you go to the assignments area, you see I have here, and this should be on your screen. And I ask my thumbs up people, do you see it on your screen now? Thank you. You'll see the lab safe, lab number 1. And the Tuesday before any lab by 5 o'clock, if not earlier, I will have this posted for sure by Wednesday morning, 7 a.m. at the latest, but I'm going to always shoot for Tuesday afternoon. Part of the reason I'm saying that is the labs that I got, and not only me, but all the Chem 1211 instructors from the coordinator or the department chair, Mary Newberg, I'm modifying them to make them better for you. She's done a good job, but I've modified them. And you should be downloading these because you'll be doing this. This lab and all labs are due the next week as per my syllabus. You'll upload them through the assignment area. Now, because of the way the upload works, I don't think you can do 2 separate files. So the home safety contract, I think you'll just have to email to me your lab upload, but it's not due today, so relax. Let's take a look at today's lab. Today's lab deals with safety. And you should see, I ask my thumbs up people. Does everybody see the picture of required lab attire on your screen? You see that? Someone said they uploaded 2 files and it worked. Okay. The thing is, the way it's set up, it only lets me grade the last file. So it might let you upload 2, but it still might not work. All right. Can you see the lab safety where it says, please watch video in red on your screen? Give me a thumbs up. All right. That's the problem with Zoom because Zoom says you should be able to see it. Now do you see it? Thank you. And I apologize, but it's something out of my control. All right, let's go through this. Each lab will have stuff, and I'm going to go through, and then you'll be working with your chemical kit in your home, which is something new for all of us. But anyways, when you're working in the lab, or in your case, in your home with the lab chem kit, it's important to be safe. And in this video, or in this lab, Mary found a number of YouTube videos, and she had a lot more. The ones where I say in red, watch this video, you should watch those. Now, couple things. If you were in the lab at COD, you'd see this actual, what you see on your screen, on the wall in each lab, and we're required to have students, and it's good safety. One, if you have long hair, you should tie it back. You should have safety goggles, not glasses. In your kit, they gave you a pair, or I shouldn't say they gave you, you bought. Wear proper clothing. You should cover all your skin. You've been given gloves. Wear those. I will, always do. Wear pants or something like that to protect your legs, and closed shoes in case you break something. You never want to be wearing flip-flops when you're dealing with glassware, which you will in some of the labs, because you can drop it and break it. Now, they talk about safety equipment. I'll ask you to watch this YouTube, just the one in red. When you're doing it, make sure you have good ventilation, open a window nearby. I'm going to highly recommend all the labs will be doing, you do in your kitchen, actually do it in your sink. Make sure it's cleaned out first, but do it in your sink. Now, I'm going to try and make sure that we don't have to use the alcohol burner, because that concerns me. And I'm going to go through each lab and see if I can find a way where you can do something where you just boil water first and use that on your stove, which I think is safer for you. You should never have any food around or dishes in your sink when you're handling chemicals. Keep some water nearby. That's why I say do it in your sink. If you ever get any chemicals on you, the best thing to do is rinse it with cold water for about 15 minutes. And if it's still bothering you, and we don't have, except for one chemical, anything dangerous, get medical attention. If you break glass, don't pick it up with your hands. Use a dustpan and a broom. If you don't have a dustpan, get a couple pieces of cardboard, that will work, but you should have a dustpan around. If you have a fire extinguisher, keep it by. I have one in my kitchen. Never had to use it, but it's still there. Now, when you're dealing with chemicals, in Mary's right up here, she calls it an SDS. I like calling it MSDS. That's the same thing. That's called the Material Safety Data Sheet, or SDS says, the safety data sheet. And every chemical has one that's sold in the United States or shipped in the United States. And all the chemicals in your box, you have them. Now, important thing in the MSDS are the hazard. And there are two different scales. And the one I'm asking you to look at is the NFPA, when I forgot what National Fire Protection Association or something, whatever that stands for. And you see these different colored squares in this square, and they're diamonds, and there's a number in there. And blue is health, red is fire, yellow is reactivity, and white is special hazard. I guess I am a special hazard. No, but I shouldn't joke about this. The higher the number, the more hazardous it is. When it's 4, it's quite high. When it's 0, it's not hazardous. And the thing I'd like you to look at is the blue one. Now, how do you find an MSDS sheet? Everybody, can you see Google search box, search the web on your screen now? Thank you. Especially Diana, who seems to be the first one I see. Thank you. All right. Now, if I was looking for a chemical MSDS, and this is good for the rest of your life to know. If you're ever looking at an ingredient label of something you bought or want to buy, you can look up how dangerous are chemicals in there. This is not in your kit, but it's a chemical I'm familiar with. If I can spell it, put the name of the chemical, then put in MSDS, hit enter, and you'll notice we have the material safety data sheet from different companies. Fisher is a well-known respectable company. If I click on this, and this is an older style one, let's see if I can find a newer style. This is still older style, but they're about the same, but I want to find. All right. Well, anyways, you would have seen probably, well, here, you would have seen a 4 in that blue square, which means it's a hazardous chemical. Let's see if I can't find one. All right, Murphy's rule. Anyways, when you look at a MSDS sheet, the first section will give you the name. The second, hazards. And if you see a symbol, hazardous, like this on your skin, or the one I showed you, and the ones in your things I found MSDSs. Part of today's lab, you're going to have to look up the MSDSs for some of them and find out certain hazard class. And it has other things like how to store it, composition, first aid, what happens if you eat it, what should you do if you get it on your skin or other things, what happens, what you should know, how flammable it is. And these are all important things in the MSDS sheet. And what I'm going to ask you to do, I'll show you in a little while. Now, a couple of important things you should never eat or drink while you're working in your lab. Some of the time you may have to dilute stuff if you spill it. Just let the water run. I would clean it when you're done with soap and water. Clean your gloves before you do with soap and water. And one of the things you don't know, if you're ever in a chemistry lab or in a chemical plant or somewhere, you know how you can tell a chemist? That's someone who always washes their hands before and after they go to the restroom. Because if you're handling chemicals and you go to the restroom, you never want to get chemicals where you don't want to ever get chemicals. I worked at one chemical company where a plant worker didn't follow that. He got chemicals in a chemical burn where he didn't want ever. And took a couple months before that. He was well again, that part where you don't want chemicals. And it took a lot longer before people started, how should I say, hazing him what an idiot he was, which he was. So always wash your hands after, even with gloves on. I will. And for at home, you should read this. And I'm going, well, wait, is this the contract? All right. I'll go through this in a second, more than a second. Now, for today's lab, after you've read what's here, and this is something you download, I have some questions. And first of all, print your name here, because these pages you'll be handing in, and you have these questions. And I'll ask you to fill them out and upload these. These are due next Thursday by, I think I have 10 p.m. And example, what's the NFPA health rating for calcium hydroxide, sodium carbonate, copper sulfate? Those are 3 of the chemicals in your kit. That's why I put them down. And notice 9, I asked what chemical is the most hazardous. Remember, 0 is the least, 4 is the most. If you look up here, how do you find the MSDS for a chemical? Well, I just taught you that. Also, I'm going to ask you what chemicals are in your chemical kit, and this is what you'll do. All right. If we're in the lab right now, we have a little different one, but we do have a similar one. And I'm going to ask my thumbs up people. Do you see the at-home student chemistry? Thank you. All right, let's go through this. If possible, only work when another adult is. Generally with chemicals, you should never work alone. All right, you should work in a well-ventilated area. You should dress properly. Always wear goggles and gloves. If you're careful, you don't have to wear the lab apron, but if you want, you should. You've been given one in the kit. When you're working with stuff, you should never be eating, drinking, especially smoking, and you shouldn't be chewing gum either. You shouldn't be putting on cosmetics. Well, if you're in the kitchen, well, anyways, you should never taste or smell any of the chemicals, and you shouldn't do anything distracting while you're dealing with a chemical lab, like texting or using your cell phone, except to call someone in case of emergency. Well, be prepared for emergencies, work near water. That's why I'm asking you to work near the sink. You should never get it in your eyes because you always should have your goggles on. Flush the water with water if you ever do get anything in your eyes and they get medical attention, but you should always have your goggles on. Don't have them on your forehead. Don't have them around your neck. You should use a broom or dustpan. Don't use your hands to clean up broken glass. And ideally, you should have it. Try and keep the area clean for you're working. If you're working in a kitchen, make sure there's nothing nearby. The chemicals in your kit shouldn't be stored where children or pets can get into them. Keep chemicals in the original containers. Store similar coated bottles. All right, I don't think we're going to be doing that. When you're through, you can dilute most of the water and down your drain. At the end of the term, excess, they call it hobby chemicals, bring to the Illinois hazardous waste or return to COD at a designated time. I'd take it to COD. It's probably, I don't know if Illinois hazardous waste will charge you. I don't know, I've never used them. Always remove your gloves, and I'd wash them too before you remove them, and wash your hands too. And if you're pregnant or have other special needs, let me know or consult with your physician. We don't have anything really dangerous. By the way, yes, I have had pregnant students in my labs, and they all had children who were doing well. After the lab, they were doing well too. Now, listen carefully. I need you to sign it, date it, put the course and section. If you want to put my name, you can, you don't have to. And that would be CHEMI 1211 net 05. Again, course and section. I need this as soon as possible. I'd like hopefully by next Wednesday for you to have this, because I'm going to take these, always upload these as a PDF in the Blackboard. I have how to make a PDF file with your, let's take a look at it. Oh no, it didn't get copied over. I'll be putting right here by tomorrow. They'll be right here, a selection which will say how to make PDF files. And I'll have a PDF and a Word file that explains how to do that and how to upload it via assignment. For this one, I would ask you, instead of using assignments, can you directly email me the at-home safety contract? Directly email. Next week, you upload in all labs, upload this through assignments. And that's today's lab. Any questions about today's lab? Again, you should download that, both the contract, which is in the assignment area, and the actual lab. Hold on. Labs are thirsty business. The course is CHEMI 1211 space NET 05. We're section net 5 of CHEMI 1211. I'll say it again in slow motion. CHEMI 1211 space NET 05. Dr. White's being silly. I do that sometimes. Life should be always enjoyed. Important thing, never ever lose the little child in you. Always let that be somewhere so it can come out and have fun. All right, with that, it is very important that you get me the contract, say by next Wednesday, signed and uploaded as a PDF. I will be taking those and forwarding it to the laboratory manager who keeps them on file at COD. I also keep a copy myself. And in real life, if you were in the lab at COD, we have a slightly different one, but it's almost the same. There are other things we put because you're in the actual lab that were as opposed to your kitchen, and essentially identical to that. And that's also signed by you. And I give those to the lab managers, not only me, but every instructor. Guess what? With that, I'm done for today. And I will say, first of all, don't forget the Chem 1211 YouTube channel is up and running and open for business. By 5 o'clock this afternoon, if not earlier, I'll have this lecture and lab Zoom meeting in YouTube. Remember, go to YouTube, put in CHEMI space 1211 space COD, or look for the link in my syllabus, and that will get you there. And with that, I get to say, have a nice rest of the week and the weekend. I'll see you next Tuesday. Don't forget, if you have any questions, you can always email me. My office hours are next Monday and Wednesday. You're always welcome there. And with that, I'll say goodbye, gay and gesund. I'll see you on Tuesday. Bye.